Let's talk about acids and bases. In this chapter, let's start with the definition of how to define the acids and bases according to the Bronsted-Lowry theory. According to the Bronsted-Lowry theory, Bronsted acid or an acid is uh, categorize or acid is a substance that can donate a proton. As an example, if I look at this hydrochloric acid, it is in equilibrium with water by releasing an H plus, releasing an H plus. That H plus is accepted by the water molecule and that water molecule becomes H3O plus. And we will have only the chloride ion. So HCl is known as the acid. After losing H plus, it will become an conjugate base. And a base is defined as a substance which can accept a proton. Ammonia in equilibrium with water, water releases a H plus and that H plus is accepted by the ammonia and becomes NH4 plus. After releasing a H plus from water, it becomes OH minus. So ammonia is the base and NH4 plus. After accepting H plus, it becomes the conjugate acid. Here in this picture, you will see again the relationship between the acid and the conjugate base and the conjugate acid. A base become a conjugate acid after accepting a H plus. Acid becomes a conjugate base after releasing or after losing a H plus. So they are all in the aqueous mode. So they all we can consider them in equilibrium in water. Here are some examples for Bronsted acids and bases. The acetate ion is the conjugate base of the acetic acid. OH minus is the conjugate base of water. And like all these things, the conjugate bases are resulted after losing H plus from the acid. Again, the conjugate acids are resulted from the bases by accepting an H plus, adding a H plus ion. So adding this hydrogen and a plus positive charge. So you need to consider the net charge of the resulted molecule. As an example, H2O plus becomes H3O plus. OH minus become just the neutralize, like OH minus accepting a H plus becomes H2O. The positive to negative charge will cancel out and we'll get a neutral H2O molecule like that. Here is your turn. What is the conjugate base of HNO3? So let's write the uh, equilibrium for this nitric acid in water. So this is the acid. Acid becomes a conjugate base after releasing a H plus. So then that H plus will be uh, accepted by water molecule and become H3O plus A cube, and NO3 is the conjugate base of the nitric acid, like that. Here I have given the answers for that. And look at the conjugate base. Okay, let me do one more thing. The conjugate acid. Look at the part D. Conjugate acid of the bicarbonate ions. HCO3 minus. And let's write it with the uh, equilibrium in water. And so this is the base and conjugate acid. It becomes a conjugate acid after accepting H plus. So after accepting H plus, it becomes H2CO3 AQ, and water become OH minus ion. So this is the conjugate acid of the bicarbonate ions.